Hi, I'm Olga Mali and this is Math Talk. My guest is Ty Lewis, student of our college, and he agreed to help me again. Hi Ty, how are you?
Hi, Professor Mali.
So today we are going to work with systems of linear equations in two variables, and we will describe substitution and elimination or addition methods. And we will just work with one problem. My problem will be about river and boat. So Ty, I want to ask you a question. If suppose this is your house, so this is your house, and you want to visit your friends. So here is where the friends live. And you have two options. You can go by boat over the lake, or you can use the river. And river moves this direction. Imagine you have a boat, a rowing boat. Which path would you take to get to your friends?
So to get to my friends, I would take this path.
River?
Yes, the river.
Why?
Because the current is pushing me.
So it will help you, yeah? You will reach friends faster,
yes.
Right? Okay, great. What will be your return path? How would you go, by river or lake?
So my return path, I would go by the lake because I'd be going against the current, whereas if I go through the lake, I'd just be going through.
So it will be just speed of your rowing the boat, right? So you are moving in still water. Okay, great. So now we're ready to read our problem, what we have here. So we have Bob and Linda rowing their boat at a constant speed, 27 miles downstream for 3 hours. So downstream means we are moving and current helps us. Then on the trip back, they're moving against the current, and trip takes 9 hours. We need to find the rate of the current. So here is our situation. This is a river which moves this direction. So this is current. So current moving this direction. And here is our boat which moves the same direction and moving 3 hours. Okay, so Ty, can you do the same picture of them moving back?
Okay, so the picture, so in this case, the current is still going this way. However, the boat is moving the other way, and it's doing it for 9 hours.
Okay, 9 hours. But the distance is the same. The distance is still 27 miles. So here we have 27 miles, and distance here is also 27 miles. So we need to understand that when we're moving along with the current, as Ty previously told us, the boat is moving fast, and we can see according to the time, it takes only 3 hours going there and 9 hours going back. So it means that we are moving faster, and we need to add speed of the current to the speed of our boat in still water. So let's assign two variables. Let's say that we have B, that would be speed of the boat, in still water. And we will have C, that will be speed of the current. Speed of the current. So what does it mean? When our boat goes this direction together with the current, speed will be B plus C. Remember, B is speed of the boat in still water. In still water. So the current helps, so the real speed of the boat will be B plus C. On the return, the current will slow us down. It will slow down that boat, so the real speed of the boat will be B minus C. So with this speed, B minus C, the boat is moving 9 hours, covering 27 miles. And with this speed, B plus C, we are moving 3 hours and covering the same distance of 27 miles. So equation which we are going to use is very simple. We know distance is rate times time. So rate is speed of our boat. So let's create a small table. What do we have? We have two cases. We're moving downstream and upstream. And upstream. And we have speed of the boat. This is boat. Rate. We can put it as a rate. Then we have time in hours. And we have distance, which is distance is equal r rate times time. So for downstream, what do we need to write here? Speed is b plus c. What do we write here?
B minus c.
Okay, b minus c. Now we know time. It took 3 hours to get there and 9 hours the return trip. And distance we know is 27 miles. It's the same. So that means we are getting two equations. Rate times time is distance. So we need to write rate b plus c times time equals 27 and b minus c
times 9.
Now it's time
is also 27.
Is also 27. So we got two equations with two variables b and c. And now we need to solve this system of equations. So let's say step number 1 would be just to distribute 3 and 9. So we can rewrite them as 3b plus 3c equals 27 and 9b
9 minus
9c,
c
yeah,
equals
27. Okay, so let's try to solve the system of equations by elimination method. So Tai, what variable you would eliminate? So we need to remember that elimination method or addition method works when we have coefficients of one of the variables are opposite numbers. So which variable you would eliminate here?
So I'd eliminate c by multiplying the top equation by 3 and then adding the equations.
Okay, let's just have a new paper here, and I will just rewrite our equations. So we have 3b plus 3c equals 27 and 9b minus 9c equals also 27. We multiply the first equation by 3, and in this case we will get here 9c, which is opposite to this. And then with the next step, when we add two equations, c will be eliminated. Okay, Tai, so what do we get when we multiply the first equation by 3?
We get 9b plus 9c
equals 81. The second equation we just rewrite. Okay, great. And now we can add them. That's why the method is called addition or elimination, because we eliminate one variable by addition. Okay, so what do we get?
We get 18b. Now these 9c's, because you have a plus and minus, they cancel out, so this would just be 0. I'm not going to write it. But this would just be 0.
Yeah, and we're
and
at 81 and 27. We get 108. Okay, great. So this one gives us b right away. We divide everything by 18 and we will get 6. But this is not the answers. B was speed of the boat in still water. We need to find rate of current. So how do we find C?
So we can substitute this b back into one of the equations. I'd suggest we do the top one.
It's easier,
because
right?
we have bigger numbers and a minus sign in the bottom one. But you
Okay.
can do the bottom one if you want.
Okay,
So-
let's do the first one.
So the top one would be 6 times 3 is 18, plus 3c, we don't know c yet, is equal to 27. And we can subtract 18 from both sides to get 3 times c equals 9, or c equals 3. So the rate of the current is 3 miles an hour.
Okay, great. So we now answered this question. Now let's think about this. It looks like we did a little bit of extra work here because we first found B, which we actually don't need, right? And then we had to do something else to find C. How to find C right away from this system of equations? What if we eliminate B?
So
Can
this
we do
means
that?
instead of multiplying the top by 3, we have to multiply it by -3.
Okay, so let's use another board and let's try it. So we have the same system of equations, 3b plus 3c equals 27, and 9b minus 9c equals 27. So now we want to eliminate b terms. That means, as Ty said, we multiply the first equation by -3. Let's check. In this case, this number will become -9, and then when we add two equations, yes, b will be gone. Okay, Ty, continue. So what do we have from the first equation? Let's check it.
So we have -9b minus 9c equals -81.
The second equation we just rewrite.
Yeah, 9b minus 9c equals 27.
Okay, now we're ready to add them up vertically. Now b will be eliminated, so b is gone. And what's left here? We have -18c equals to
54.
-54. This number is negative and this one is positive, so we get -54. And now again we divide
C
and we will get 3. So we find speed of current a little bit faster in this case. Okay, now one more thing. What if, before even multiplying or doing anything, what if we just look at our equations and we notice something? What if we notice that in first equation, all coefficients are divisible by 3? Can we simplify equation?
Yes, you can.
The second equation has coefficients all divisible by 9. We can also simplify.
Yes, yeah.
So let's just divide the first equation by 3. All coefficients we will divide by 3. So we'll just get b plus c equals to 9. Now we'll divide all coefficients in the second equation by 9. We will get b minus c equals to 3. This system of equations is very easy. We can solve it again by elimination method. So which we can do very quickly, just adding two equations vertically, right?
Yeah,
so c will be gone right away.
Yeah.
So we will get b equals to 6, and then from here we can find c, right? Substituting. We can substitute
yeah, it's pretty easy to substitute.
in which equation, like any equation,
either equation,
right?
it's very easy to
Yeah,
substitute.
so let's say I want to use first equation. I will write 6 instead of b plus c equals to 9, and I can find c is 3 very quickly. So if you notice that coefficients in the equations can be divided by the same number, use it. It makes your life easier. Okay, so we talked about elimination method everywhere. Now let's have a look how to work with substitution, and I will just use these two equations. I will just rewrite them here. b plus c is 9 and b minus c is 3. So, Ty, how would you use substitution method? We remember for substitution method we need one variable with coefficient 1 or -1. Here we have all sort of variables with coefficients 1, -1. So which one would you use?
So I'm going to use c and substitute everything for c. So what I do is I'd subtract b from both sides. So I'd have 9 minus b.
And then you just put it here, right?
Yes.
So what
So
do
then
we
you'd
get?
have b minus 9 minus b equals 3.
Okay, and then we can solve it for b, right?
And then this would be 2b
minus 9
minus 9 equals 3. 2b equals 12 and b equals 6.
Yeah, so we get the same answer for the speed of the boat in still water. But since we need to find c, it would be faster probably to eliminate b, say, from the first equation. So I can write b equals 9 minus c, and then I will use it for the second equation. 9 minus c equals to 3, right? So we have 9 minus 2c equals 3. and negative to C will be equal negative 6, and C will be 3. So we get speed of the current. So there are different ways of solving this problem. You can use a substitution method. If you notice that you can divide out coefficients and get very easy system of linear equations, or you can use elimination or addition method. If you don't notice that you can reduce coefficients. Okay, Tai, thank you so much. That was great, and I hope we helped our students. That was Olga Male and Math Talk. Thank you for watching.